Hello students, welcome back to my channel CSIR Buddy. In this particular video, we are going to study about slow block to polyspermy. As we have already studied about the fast block of polyspermy in the previous video, of which the link I will be providing in the description section. But for the glance, I would recall this fast block to polyspermy to you all. So in the case of fast block to polyspermy, it was happening within some seconds, like 10 seconds. So in this case, we were getting Na positive channels were getting opened. Hence, polarity was changing. That means the membrane was getting depolarized. And once the membrane got depolarized, the entry of the other sperms were getting inhibited, right? So you can recall all these things in the previous video. Today we are going to study about the slow block to polyspermy. Now what is slow block to polyspermy? Once the fast block has happened, अभी हमें पता चला कि fast block हो गया है, that means depolarization has been occurred. Now what? Fast block of polyspermy ends for some seconds. It can't hold everything. So we need a permanent solution so that the situation of polyspermy, that means entrance of more than one sperm, is prohibited. Right? So in this case, what all steps are happening? Let's get started. Once the sperm gets into the cytoplasm, it releases an enzyme called sperm specific, that is phospholipase C zeta, that is PLCz. So once the sperm is entering the cytoplasm, it is releasing some of the enzyme that is known as sperm specific enzyme, which is the PLCz, into the cytoplasm. Now PLCz binds to rough endoplasmic reticulum. Rough endoplasmic reticulum means the ER present in the cell. This binding triggers a chain of events which leads to release of several waves of calcium ion from the oocyte's endoplasmic reticulum. Now as we all know that endoplasmic reticulum stores the Ca2 positive, that is calcium. Now PLCz will undergo some of the reactions and will open this gate so that the calcium ions would easily come out of the ER. Right? This was the ER. Now what will happen? So this is a particular diagram. This is the ovum which we have, and these are the layers which we have already talked about in the previous videos, wherein I was telling you about the structure of ovum. So the structure of ovum is like that it is having some of the layers that are known as ZP1, zona pellucida 1, zona pellucida 2 and zona pellucida 3. Now in all these three layers consist of NAG. NAG is N-acetyl glucose amidase, will digest NAG, hence blocks sperm interaction. Now this NAG would be blocked by the digestion of glucose amidase. So this glucose amidase would digest this layer of NAG, and once the NAG is digested, what will happen? Now what will happen? NAG digesting enzyme, that is N-acetyl glucose amidase enzyme which digests the NAG. Right? Now what will happen? Once the sperm has interacted with the ovum, it will activate this PLCz. PLCz would activate PIP2, and then PIP2 will activate IP3. Right? This IP3 would bind to the ER. So it is binding to the ER membrane, hence releasing the Ca2 positive, that is calcium ions. Now this calcium would bind to this granules. So it will bind to the cortical granule, thus releasing the enzyme, that is NAG digesting enzyme, which is N-acetyl glucose amidase. So this enzyme, which is protruding out of the cortical granules, it will digest the NAG, which is the ZP1 layers, right? So it would digest the NAG. This enzyme would digest the NAG, right? So this was the chain of reactions which is following up to the release of calcium ions. Once the calcium ion binds to the cortical granules, it will result into the digesting of the NAG layers, right? So this was the process of slow block to polyspermy. Now moving further, calcium waves to the following. Now as we know that सारा जो भी chain of reaction हुआ था, that signaling was up to the release of the Ca2 positive. Now Ca2 positive, after binding to the cortical granules, release some of the enzyme that was known as glucose amidase. Now let's see the functions of calcium waves. It stimulates restart of the secondary oocytes, right? Now it would restart the secondary oocyte which was stuck in the mitotic division, that was MP2 phase, that is second mitotic division. So as we all know that the oocyte is stuck before fertilization in the metaphase 2 stage. Metaphase 2 stage. And once the sperm has interacted with the ovum, it again restarts its meiosis, right? Causes special cytosolic cortical granules to fuse with the oocyte's plasma membrane and release their payload into the perivitelline space, right? So we have already seen that cortical granules से Ca2 positive bind होता है and it would help in the release of the certain enzymes which would digest the plasma membrane or the zona pellucida layers. Now polysaccharides then diffuse through the perivitelline space and soak into the zona pellucida. Now the polysaccharides released through the cortical granules would diffuse through the perivitelline space and would interact with the zona pellucida layer. Polysaccharides contacting the zona pellucida layer cause it to thicken and stiffen. Now through the interaction of these polysaccharides to the zona pellucida layer, it would thicken the outer layer of the ovum so that no other sperm would be able to enter into the egg. Sperm have great difficulty getting through the thick and stiff zona pellucida, so that this causes thickening and this would inhibit the sperm to enter the zona pellucida layers. Now this stiffening is called the zona reaction. So this particular thing is known as zona reaction. So I think this slide was clear to you all. You can have a screenshot, you can take a screenshot, or else I will provide the PDF of the same in the description section. Now cortical granules enzymes. So what are those enzymes which the cortical granules releases? So proteolytic enzymes destroy the remaining ZP3 molecules on the zona pellucida. The proteolytic enzyme which would digest the proteins. So those enzymes are known as proteolytic enzyme. So they would digest the ZP3 molecules on the zona pellucida layers. Now the sperm can't bind to the zona pellucida, hence inhibiting the binding of the other sperms. This yet another deterrent to additional sperm binding. Both of the aforementioned mechanisms make it extremely difficult for other sperm to enter the cytosol of the oocyte. So this process would make the sperm entry very difficult. So it would inhibit the condition of polyspermy. So this was all about the inhibitants of polyspermy, or the sperm to enter the egg through the slow block polyspermy. So the slow block polyspermy is more efficient than the fast block polyspermy. So because it would hold the sperm from entering to the ovum for a very much longer time as compared to the fast block polyspermy. So that was it for this video. I hope you enjoyed this lecture. If there is any doubt regarding this lecture, you can have a comment section. You can tell me in the comment section that what were your doubts. And if you like this lecture, please like, share and subscribe to my channel and help me to grow faster and faster. Thank you.